How to balance the reaction between potassium permanganate and hydrogen peroxide in the presence of potassium hydroxide, which means in the basic medium. When we consider permanganate ion, there are two reactions of permanganate ion. Permanganate ion converts to manganese ions. Permanganate ion converts to manganese dioxide. This conversion takes place in an acidic medium. The formation of manganese dioxide takes place in a basic medium. There is potassium hydroxide. Potassium hydroxide is basic. Therefore, during this reaction, permanganate ion reduces to manganese dioxide. Oxidation number of manganese is +7. Oxidation number of manganese is +4. Therefore, 3 electrons were gained. Overall charge in the reactant side -4. In the product side, it's 0. Therefore, we need to add 4 hydroxide ions to product side. Then overall charge is balanced. Then we need to consider number of hydrogen atoms. In the reactant side, there are no hydrogen atoms. In the product side, there are 4 hydrogen atoms. Therefore, we need to add 2 water molecules to the reactant side. Then 6 oxygen atoms. 6 oxygen atoms. That reduction, half reaction is balanced. Then what about hydrogen peroxide? Hydrogen peroxide can release electrons while converting to oxygen, or hydrogen peroxide can gain electrons while reducing to water. During this reaction, permanganate ion reduces. Therefore, hydrogen peroxide should release electrons. Gain of electrons, then release of electrons. Therefore, the reduction of hydrogen peroxide is not valid in this case. Oxidation number of oxygen is -1. Oxidation number of oxygen is 0. -1 to 0. Release of 1 electron. There are 2 atoms. Therefore, 2 electrons were released. Then overall charge in the reactant side 0. Overall charge in the product side -2. Then we need to add 2 hydroxide ions to reactant side. Then 4 hydrogen atoms. We need to add 2 water molecules. 4 oxygen atoms. 4 oxygen atoms. The reaction, the half reaction is balanced. Then we need to add reduction reaction and oxidation reaction. Before that, we need to match the number of electrons. Therefore, we can multiply the reduction reaction by 2. The oxidation reaction by 3. Then add those results. 4 water molecules, 2 permanganate ions, 6 electrons, 6 hydroxide ions, 3 hydrogen peroxide molecules. Products are 2 manganese dioxides, 8 hydroxide ions, 3 oxygen molecules, 6 electrons, 6 water molecules. 6 electrons, 6 electrons, 4 water molecules, 6 hydroxide ions, 8 hydroxide ions, 2 remains. Then we can write 2 potassium permanganates. 2 potassium ions are excess in the reactant side. Then 3 hydrogen peroxide molecules. What are the products? 2 manganese dioxide, 3 oxygen molecules, 2 water molecules, and 2 hydroxide ions. We can write those 2 hydroxide ions with 2 potassium ions, then 2 potassium hydroxides. Therefore, this is the balanced chemical equation for the reaction between potassium permanganate and hydrogen peroxide in the presence of potassium hydroxide. So there is a bit confusion. What is that confusion? Potassium hydroxide is in the reactant, not in the reactant side, but in the product side. What is the reason? That is how the reaction balanced. So what is the purpose of potassium hydroxide adding to the reaction mixture? It keeps the mixture or the reaction medium basic. Therefore, the acidic reaction doesn't take place. That's how we can explain why potassium hydroxide is in the product side. Want to master oxidation and reduction better? Then get oxidation and reduction workbook. It is full of easy to understand explanations and practice questions. Want to score high in your term test and aim for that A+ in your advanced level exam? Join our smart paper discussion class today. Scan the QR code or click the link in the description to get started. Stay curious, stay focused. See you in the class.